Hello listeners. Today I will tell you about what sort of data do you need from the motor vendor in order to create the motor model for its dynamic studies. So basically motors are generally used in both industrial and domestic application. And specifically if I talk about the operation of an induction motor, it runs due to the induced electric current in the rotor circuit by varying the magnetic field in the stator windings. The rotor current produces its own magnetic field, which then interacts with the stator field to produce particular torque and rotation. And this accelerating torque basically creates the voltage dip. And this voltage dip becomes the source of many problems like they decrease the voltage at the bus terminal, affects the overall motor starting performance, and the motors that are running in normal condition, because of this dip they may slow down, and this voltage dip may affect the other electronics and sensitive devices. So if I talk about the industry standards, AC control devices must not operate below 85% of the rated nameplate voltage, and for DC it must be above 80% of their rated voltage. So as a result, study the dynamic behavior of the motor starting is critical, and engineers must know how their system behave when they are in use. So now let's come to the point that what sort of parameters you need to ask from motor vendor, which is required to input in ETAP to check its dynamic behavior. First you have to define the duty cycle, which means that whether you want to run in a continuous mode or in intermittent mode or as a spare. From here you can choose the option. So basically there are four modes of operation for motors. So these are the four modes of operation, or you can say the duty cycles of electrical motor. S1 means continuous duty. Once you start the motor it will continues to run. Number 2 is short time duty. It shows that you start a motor and you switched off. It runs for a very short duration of time. Number 3 is S3, intermittent periodic duty. You start, you stop, you start, you stop. And the last one is the continuous operation with electrical braking. You also applied braking system while the motor is running in a continuous mode. So after defining the duty cycle, you need to enter the motor kilowatt rating, number of poles, and if you want to define your own model, click here and click on the parameter estimation. So when you click on the parameter estimation tab, a new window will open like this, where you need to put the information of lock rotor and full load. These informations are available on the nameplate of motor. First you have to enter the lock rotor input current, power factor, and these two torques. The first one is known as the lock rotor torque, which is also called the starting torque of the motor. The second torque is called as the braking torque, the breakdown torque, which is the highest torque available before the torque decreases when the machine continues to accelerate to working condition. A brief summary about the torques in electrical motors. So there are four types of torques. Number 1 is lock rotor torque, which is also called the starting torque, as I told you. Number 2 is the pull-up torque, which is the minimum torque developed by an electrical motor when it runs from 0 to full load speed. The third one is the breakdown torque, as shown in the picture. It is the maximum torque before going down to full load torque, or you can say that the normal rating torque. Next you have to enter the slip ratings, power factor and efficiency of the motor. So once you enter the parameters of lock rotor and full load, just click on this estimate button. You can see these values will automatically calculate by ETAP program. Next is to update the motor parameters by clicking just update button. This is how you can design your own model for motor. So after defining the motor model, next you have to enter the inertia value here, and then click on the load tab. You have to mention the percentage speed versus percentage slip, or percentage speed versus percentage torque, whatever the data is available on data sheet. So once you develop the motor model by putting the required parameter, just apply the case study and check the behavior of motor and also the voltage status on the bus bar. So when I run the transient stability, I can see the results as shown on the screen. At 1 second the motor starts and you can see the voltage dip here on the bus bar. That comes to the normal voltage rating gradually. So this is how you can observe the transient stability.